Welcome to the DIY Honda Garage channel. DTC P16F8 stands for Starter Inhibitor Relay Stuck Off and is relevant for Honda Civic models from 2011 to 2015. This diagnostic trouble code indicates that the vehicle's starter inhibit relay is not functioning as expected, which can prevent the engine from starting. The starter inhibitor relay is a component that prevents the starter motor from engaging unless specific conditions are met, primarily when the clutch pedal is pressed in manual transmission vehicles. An uninterrupted signal from this relay is crucial for engine start operations. The location of the relay is typically in the underhood fuse relay box, and it interacts directly with the clutch pedal position switch and the engine control module, ECM, which is responsible for managing engine functions. In troubleshooting this DTC, understanding the operation of the starter inhibit relay and its associated components is vital. The starter inhibit relay is an essential electronic component in the starting system of the Honda Civic. It ensures that the engine will only start under specified conditions, primarily requiring the clutch pedal to be depressed. This safety feature prevents the vehicle from rolling unexpectedly. The relay is interconnected with other components, including the clutch pedal position switch and the engine control module, ECM. Its location is commonly found in the underhood fuse relay box. A malfunction in this relay could prevent the engine from starting, leading to DTC P16F8 being triggered. Therefore, fully understanding the workings and locations of these components is critical in diagnosing the issue effectively. Several factors can lead to the occurrence of DTC P16F8. First, a failure of the inhibitor relay itself may prevent proper function. This can arise from electrical malfunctions or internal relay faults, making it impossible for the vehicle to start. Another potential cause is a blown fuse, specifically fuse B2, which can impede the relay's operation. Additionally, there might be open circuits in the wiring that connect the clutch pedal position switch, the inhibitor relay, or various other components involved in the starting circuit. These wiring issues can lead to intermittent electrical connectivity and errors that trigger the DTC. It is crucial to methodically isolate and test each of these possibilities to determine the core issue. The symptoms associated with DTC P16F8 are relatively straightforward but significant. The most apparent symptom is that the engine will not start, which is usually the primary concern of drivers encountering this issue. When attempting to start the vehicle, there may be no sound from the starter motor, indicating that power is not reaching it due to the relay issue. Additionally, dashboard indicators may illuminate, such as a warning light signaling a failure in the starting system. Driver awareness of these symptoms is essential, as it prompts early intervention, helping to prevent further complications or damage to associated electrical components. Understanding these symptoms allows for quick identification of the specific problem area. The first step in troubleshooting DTC P16F8 is to verify the problem systematically. Begin by pressing the engine start-stop button to select the on mode, which indicates the vehicle's systems are powered, yet the engine has not been started. After setting the mode, it is essential to use the Honda Diagnostics System, HDS, to clear any existing diagnostic trouble codes, DTCs. Once cleared, toggle the engine start-stop button to switch to off mode before returning it to on mode once more. This process kickstarts the diagnostic routine. Following this, it is important to press the clutch pedal, as its position influences the relay's function. Lastly, the HDS should be checked for pending or confirmed DTCs to determine if P16F8 is still indicated, guiding further actions based on the results. Proceeding to the second step of the troubleshooting process involves checking the fuses. particularly fuse number B2, which is crucial for the operation of the starter inhibit relay. Ensure the engine start-stop button is set to off mode to safely conduct this check. The location of fuse number B2 is identified in the under-dash fuse/relay box. If the fuse is found to be okay, you should continue to the next troubleshooting step. However, if the fuse is blown, it needs to be replaced immediately. Additionally, it is vital to check for any short to ground in the circuit associated with this fuse, as persistent fuse failures can indicate deeper electrical issues within the system. This careful examination can prevent repetitive failures and related complications. In the third troubleshooting step, the focus shifts to assessing the inhibitor relay, a component integral to the starter system. Again, ensure the engine start-stop button is in the off mode for safety. Remove the inhibitor relay from the underhood fuse/relay box, which allows for direct testing. It's imperative to confirm that the relay is operational, as a malfunction here can directly cause the DTC P16F8. If tests indicate that the relay is functioning correctly, continue troubleshooting. However, if it is found defective, replacing the relay is necessary. A faulty relay can disrupt the entire starting circuitry and should be addressed immediately to restore proper functionality. Moving on to the fourth troubleshooting step, open wire checks are conducted on the IG1 ACG line. Set the engine start-stop button to on mode so that voltage can be properly measured. It is crucial to measure the voltage between two designated test points, the 4P socket number 1 of the inhibitor relay and the body ground. Repeat this process for test point number 3 as well. Confirm that there is battery voltage present at these points. If battery voltage is confirmed, this indicates that the IG1 ACG wire is functioning correctly. If no voltage is found, it directs technicians to repair potential open circuits between the B2 fuse in the under-dash fuse relay box and the inhibitor relay itself. Successfully addressing any identified faults will help move forward in troubleshooting. The final troubleshooting step assesses the NHRLY line for open circuits. Again, confirm that the engine start-stop button is switched to off for safety. Begin by removing the starter cut relay 1 from the underhood fuse relay box to assess connections. Continuity is then checked between two specific test points, the 4P socket number 2 of the inhibitor relay and the 4P socket number 3 of the starter cut relay. A successful continuity test would confirm that the NHRLY wire is intact. If continuity is absent, it indicates that there is an open circuit that must be repaired between the starter cut relay and the inhibitor relay. Rectifying such wiring faults is vital for restoring proper electrical signals within the starting system. After troubleshooting and making repairs related to DTC P16F8, it is essential to conduct a final verification to ensure everything is functioning as intended. Start by rechecking all connections and components involved in the previous steps. Use the HDS once again to search for any DTCs, specifically looking for P16F8. If no faults are indicated, it corroborates the success of the previous repairs. A test drive may be advisable to ensure the vehicle starts without issues under real-world conditions. This step is crucial for documenting the successful completion of repairs and confirming that the vehicle is safe to drive. After verification, ensure everything is restored to its original state with all covers and components reassembled properly. To prevent future occurrences of DTC P16F8, implementing a schedule of preventive maintenance is crucial. Regular inspections of all electrical connections involved in the starter and inhibitor systems help catch potential issues before they escalate. Diagnosing the vehicle with the Honda Diagnostic System, HDS, on a routine basis can uncover hidden faults that may not yet trigger a DTC, but could lead to problems later. Timely replacement of worn-out or aging components, such as relays and fuses, will also help maintain vehicle reliability. Keeping a log of any previous issues and repairs can provide insight into recurrent problems, assisting in proactive maintenance strategies. By committing to these practices, drivers can significantly reduce the risk of unexpected breakdowns. In conclusion, DTC P16F8 highlights important safety features integrated into the Honda Civic starting system, specifically related to the starter inhibit relay. A methodical approach to troubleshooting allows technicians to isolate issues effectively and implement the necessary repairs. Each step, from verifying symptoms to conducting wire checks, is vital in determining the root cause of the issue. Familiarity with the system's components, like the inhibitors and relays, improves diagnosis accuracy. Regular preventive maintenance practices not only prolong the life of these components, but also enhance overall vehicle reliability. Ultimately, recognizing and promptly addressing DTCs ensures a safe and functional vehicle, preventing costly repairs and potential hazards. Please like and subscribe to the channel. See you next time.